So 12.10, practical maximum and minimum problem. So in 12.9, we learn how to find the maximum point and minimum point. So to find the maximum point and minimum point only is pointless. Okay. So we find the maximum and minimum value is so that we can solve a real life problem. Okay, it is practical. Okay, so over here they say that there are many problems for which you need to find the maximum or minimum value of a function, such that the maximum area that can be enclosed within a shape or the minimum amount of material that can be used to make a container. So we look at this example. So we have this. Okay, so you imagine that this is a 24 cm by 15 cm sheet of metal, and then they have a square side of x cm removed from each corner. The metal is then formed to make an open rectangle box of depth x cm and volume v cm cube. Okay, so over here we have a square here. Okay, and this square is actually the base for the container. Then we fold up, fold up, fold up, fold up, then it will become this one. Okay, so this will be xcm here. So over here will be 24 minus 2x. Okay, and then this part is x also, this part is x. So for this part will be, so it will be 15 minus 2x. So this one is 24 minus 2x. This is 15 minus 2x, and the height is x. So they want us to show that the volume is this. Okay, so the volume will be uh, this one multiply this one, and then multiply with the x. So the volume is the x multiplied with 24 minus 2x multiplied with 15 minus 2x. So 15 minus 2x, yes. Okay, so we multiply it, then what we will have will be x. Okay, 24 times 15, 24 times 15, 360. Okay, minus 48x minus 30x plus 4x squared. Then we have the 360x, and then over here we sum up, we will have the negative 78x. So it will minus 78x squared plus 4x cubed. So v cube will be this one. We rewrite this. So the v, the volume is 4x cubed minus 78x squared plus 360x. Okay, so this is the volume shown. Okay, so they want to find the stationary value of v and the value of x which this occur. So the stationary value of v, that is the dv dx equal to 0. Okay, so we have the v here. Okay, so this is a, and then over here shown, and we have the b here. The dv dx is 12x squared minus 156x plus 360. So we have the 78 times 2 is 156. So we have the dv dx equal to 0. So imply that we have the 12x squared minus 156x plus 360. Okay. Oh, okay. So plus 360, 156x plus 360 equal to 0. Okay. So the 156 divided by 12, is it possible? Yes. 360 divided by 12, also okay. So we have the x squared minus 13x okay, plus 30 equal to 0. So open the bracket, x 3 times 10 minus minus. So x equal to 3 and x equal to 10. Okay, so um, they want to find the value of v. Okay, so actually we can have the second derivative d2v dx squared will be 24x minus 156. So we have the d2v dx squared when x equal to 3, then it will become 24 times 3 minus 156. So we have the 24 times 3 minus 156 will be negative 84. Less than 0, it is maximum. Okay, then the second derivative when the x equal to 10, then it will be 240 minus 156. So this is 24 times 10, it will be 84. So 84 then is greater than 0, it is minimum. Okay, so the value of v is the 4x cubed, 4x power 3 minus 78x squared plus 360x. Okay, so when x is equal, so we have the CLC. When x equal to 3, then it's 486. And then we have the x equal to 10, CLC 10. Then the volume is negative 200. But this is not possible lah, because the volume won't be negative lah. Okay, so actually the x equal to 10 cannot. Why the x cannot be 10? Because you try to imagine we have 10 here, 10 here, already 20 ma. The width is 15. How can you cut 20 out from here? Okay, so this one is rejected. Okay, so this will be rejected. Okay, so the volume will become the 4 3 cube minus 72 3 square plus 360 times 3. So this is 486 cm cube. Okay. So determine the natural of this stationary value. So this natural for this one, okay, we actually should use this one. Okay, so this will be the C lah. Okay, so C is here. I no need to rewrite. And then this one no need to write. Okay, so the second derivative is negative 484. So this is the maximum volume. Okay, this is one of the application question for the maximum and minimum problem. So actually the real life problem for mathematics, okay, a lot can solve using dydx maximization. So the main application for dydx is maximum minimum. So in mathematics, okay, if you want to find maximum value, then first will come to your mind must be dydx. Okay, so if you have integration is the inverse of differentiation, then that one will be area. Okay, so dydx is the maximum or minimum. Okay, so we find maximum minimum dydx. Okay.